What is the degree of a differential equation? The power of the highest order derivative is called the degree of a differential equation. I will explain this definition with some examples. Now, what is the degree of a differential equation? Here are three examples that you can see. So, according to the definition is the power of the highest order derivative is called the degree of a differential equation. So, first you need to find the highest order derivative in a given differential equation. For instance, in this differential equation, the only first order derivative is present, and this is the highest order derivative in this equation, and the degree of this highest order derivative is 1. So, that is why the degree of this differential equation is 1. In second example, you just pick the highest order derivative in the differential equation and then find its power. The highest order is second order in this differential equation, and the power of this highest order derivative is 3. So, that is why the degree of this differential equation will be 3. Similarly, in example number 3, the highest order derivative is the fourth order derivative. So, we just pick the power of the highest order derivative, and that is 1. So, that is why degree of this differential equation is 1. And what is the conclusion? The conclusion is you just need to pick the power of the highest order differential coefficient that is present in the given differential equation. Don't bother if there is some other powers. We are not interested in the power of highest power of the equation. Make sure we are not interested in the highest power of the equation. If you see in example number 3, the highest power of the equation is 2, but we are not interested because according to the definition of a degree of a differential equation, we are interested in the power of the highest order derivative, and that power is 1 in example 3. Similarly, we are interested in example 2, we are interested in the power of the highest order derivative, and that is the second order derivative. So, that is why we pick the highest power, the power of the highest order derivative, and the power of the highest order derivative is 3. That is why the degree is 3, even though there is another power 4, but we are not interested in this power according to the definition. Now, there is a very important thing that you must know, that the degree of a differential equation is always a positive integer. Here you can see there are two examples, example 1 and example 2. The radical signs are present in both differential equations. If you want to find the degree of a differential equation, you have to remove the radical sign from the differential equation. The derivative of any order should be removed from the radical sign. So, by taking square on both sides, you will get dy over dx plus y is equal to x square. Now, it is very easy to find the degree right now, because dy over dx is the only first order differential coefficient is present in the equation, and it is the highest order derivative also in the equation. So, the power of this highest order derivative is 1. So, that is why degree of this differential equation will be 1. In second example, similarly you can see the overall power is 3 by 2. This is a rational power. First of all, we should remove this rational power. How we can remove this rational power? Just take the reciprocal of this power on both sides and you will get plus y, that will be equal to x plus 1 2 by 3. And now it is very easy to find the degree of a differential equation. The second order derivative is the highest order derivative in the differential equation, and the power of the highest order derivative is 3. So that's why degree will be 3.